to 15 Minutes with Chariot Solutions. My name is Keith Gregory, and today I'm talking with Drew Rogers, who is one of our consultants who specializes in DevOps work. We'll be talking about a project that we've recently been working on, deploying a web application into a Kubernetes cluster running on Azure. To get started, Drew, why Kubernetes?
Well, one of the client's requirements was have their entire application not married to a certain cloud platform. If they would want to move it, how easy would it be? And we chose Kubernetes because almost every cloud platform has a Kubernetes managed service. So if we have our full stack application running in Kubernetes, it's not going to be so hard if they wanted to move to AWS or Google or whatever cloud platform.
Okay. Could you spend some time talking about the system architecture, how it's configured inside the Kubernetes cluster?
Sure. So once traffic comes into the application, it hits an ingress controller running in Kubernetes, an Nginx ingress controller. This is good because it gives us flexibility of obviously terminating the TLS incoming traffic. And it gives us flexibility on having our own rules and being able to use Azure specific security features like a application gateway and making your own web application firewall rules. So once traffic's TLS is terminated, traffic moves forward to our front end and our back end. So the front end is a progressive web app, web server running static content. When that needs to make API calls, it calls to the back end Django server. Django server has access to a Postgres server running in Azure's Postgres service.
Okay. If I recall, the Postgres server runs outside of Kubernetes. Were there any particular challenges getting that to work?
Yeah, coming from AWS, I assume that the way Azure uses their managed database services was going to be the same, but it's just a little different. It had a couple of weird hiccups where you can't directly, once you create the database, you can't directly connect it to a subnet, which would be the subnet that Kubernetes is running on. So you have to make, in the Azure world, you have to make a private security link endpoint, which is fine. It was just a little bit different coming from AWS.
Okay. Now, to build out this deployment, you're using Terraform. Would you like to talk about it, some of the issues that you may have run into, and some of the maybe nice features that Terraform gives you working with Kubernetes?
Sure. So it was kind of a no-brainer using Terraform to deploy the infrastructure in Azure. It just gives you visibility into the infrastructure, regardless of what cloud platform you're using. The nice thing with Terraform, it has a Kubernetes provider where instead of just using kube control to deploy all your YAML files, you could have a Terraform pipeline that is fantastic because you have access to infrastructure assets that you may need in your Kubernetes configurations, and vice versa. That right there is a huge benefit. The one thing that the Terraform Kubernetes provider, it doesn't give you full access. You can't write your own custom configurations that you may need in deploying certain applications. But so far, it's been fantastic.
Great. And one of the things you had talked about getting access to the Azure infrastructure components and being able to expose them to Kubernetes. I know you had done that with Secrets Manager, and the applications are all very dependent on being configured via environment variables. Could you talk about that a little bit?
Sure. We ended up using Azure Key Vault, which is Microsoft's Secrets Manager. So we create our keys there like any other secret manager, and Terraform has a nice data resource type that will connect to your Azure Key Vault, get whatever version key you need, and deploy it. And then the way we deploy it is we have it fetch the keys from Azure Key Vault and then create the Kubernetes secrets configuration. And then once that's created, all the pods have those secrets available to them via environment variable. We did we did try other strategies. Microsoft actually makes its own storage driver for Kubernetes that would fetch secrets from a repository and then actually mount a directory with those files into a pod. Uh, it was a little bit over complex for for us just trying to get secrets, and then having your applications aware of a directory that needs to fetch secrets from just didn't really comply with our workflow.
Right. It seems also that it's tying it to Azure's particular way of deployment, so it would make it harder to move to a different
Definitely, yeah.
provider.
These Microsoft storage driver will not work in another cloud platform.
Right. And one thing that I wanted to throw out is one of the risks with Terraform is the TF state file, where every secret or any other piece of information that Terraform has to know about gets written in the TF state. And I'm assuming that you went with some form of remote TF state storage so that that wasn't available, so that could be controlled.
Correct. It uses Azure's own remote storage, where that actually will do the locking for you as well. So if multiple people are trying to get the same state, it will lock one person out, or lock everybody out but one person.
Okay, so that you don't have conflicting updates to the infrastructure.
Yeah, and everything's synced within its within its own remote storage repository.
Okay, well, that's good. Moving off the Kubernetes cluster, we were using CircleCI to actually build the application and uh, and deploy it. And again, this is kind of instead of using other tools such as a self-hosted Jenkins server, for example, this is kind of moving the capabilities out of a particular hosting provider. Could you talk about that integration? Anything that was challenging?
Yeah, so it was our definitely our first time using CircleCI. That it was a little bit. I come from a big Jenkins and TeamCity and kind of self-hosted background. I know for a fact that you run into environment issues with CI/CD pipeline services, and accessing them is a big kind of a requirement for me, is seeing why is something building the way it is in this type of environment. So I was kind of worried about coming into CircleCI because obviously it's all, it's a service that you're connecting to. I was so far. The pros definitely outweigh the cons for CircleCI. With just that one where that thing I was worried about before is connection, is that CircleCI you could actually SSH into the build that
Really?
yeah. So the build will run. If it fails, you could rerun it and it will give you SSH access, and then you could do what just like how you would do in Jenkins. Why did something run the way it did in this environment when when you're trying to debug something? Which it's a fantastic feature. But the big benefits with CircleCI is its caching layer. When you usually execute your builds in either a Docker container or a virtual machine, a very stripped down virtual machine. You're usually doing it in a Docker container. So, and then that will give you every step has a layer of caching. So it really does speed up the builds a lot. And then on top of that, uh, they have their own caching layer for dependencies, uh, which works if you have a huge yarn dependency or a lot of pip dependencies. I mean, they could get really big on the project, depending on the project. This caching layer will turn a 10-minute job into 30 seconds. It's fantastic.
Yeah, if I
Um,
recall, we're looking at close to 750 megabytes of yarn dependencies.
yes, and that's just yarn. We have a pip dependency that's definitely not as big, but yeah. And then the yarn dependency step only takes with the caching mechanism, it only takes about 30 seconds. Um,
Certainly
and
nice.
And even without the caching, implementing their own caching strategy, just to having the Docker layer caching, that step took about 2 minutes and I think 30 seconds on average. So they were already doing caching out of the box, which turned, I think it originally, the first run took about 15 minutes. And then their own caching layer, it turned it into 2 minutes and 30 seconds. And then now it's about 20 seconds. So,
Oh, that's nice. And that includes running unit tests and actually packaging up the images to upload to the Azure Container Registry, right?
correct. And also they force you to put your build configuration in the repository you're working on. I like this method because it gives everybody visibility on the build. So no developer is going, constantly pinging somebody going, hey, why is this Jenkins build failing? It's confusing. So it gives everybody just visibility into the whole CI/CD pipeline, which is a big benefit in my eyes.
Oh, I agree with that. I've seen far too many Jenkins jobs where the actual Jenkins job configuration calls out to a bunch of shell scripts inside the project that you have no idea what gets called when. And
Right.
if your Jenkins server ever goes down, you're in trouble.
Yeah, totally.
So the last part that we had listed to talk about was the images and pushing them to Azure Container Registry and tagging them. And could you go into that a little bit?
Yeah, so for access, we just created a service principal in Azure and gave it a service principal is like AIM or kind of like just an access role for an entity, and this service principal just has the ACR, which is the Azure Container Repository. It has just the push role, and that's it. So it's only push. It's connecting Azure to ACR, pushing an image, and that's it. Um, this is a brand new project. We're creating the front end, back end from scratch. So we're right now using the latest tag for the image. It's not the best protocol, and but for right now for turnover, it's doing the job. But using the latest tag, we had a couple hiccups, especially in Terraform, because you're versioning it, the Kubernetes deployment in Terraform. So if it's latest, you can't change it. Every time if you want to change the tag, Terraform's always kind of want to revert it back to latest. So, and at first during our CI/CD pipeline, when we would actually push the image and want Kubernetes to use it, we use the kube control set image command, which when it ran, it said, hey, it's latest. Even though the image might be updated, it's like, it's good, nothing to do here. So luckily, kube control has a rollout command that will roll out a deployment regardless of the image being updated or not.
Okay, no, that's good.
And also,
Um,
well, and also when you have latest is that a developer might want to ask, like, is this the actual version running? Like, what version is running in the development environment? So after the rollout, in the CircleCI, after the rollout happens, I tag a antidote into all the pods running the image. So the pods will have the timestamp of the updated image, and then the commit hash that was used during the pull request.
okay, which works well for development and the idea that we are cycling through and basically doing pushes into the shared development environment maybe a dozen, 2 dozen times a day. And then for production, I'm assuming that you'll end up being more rigorous with kube control to actually specify this is the build tag that we care about.
Yeah. Hopefully before production.
Well, that's true. Yeah, I have a staging environment and whatnot.
Yeah,
All
staging.
right.
We'll definitely have versioning when we move to staging.
Okay. So that pretty much covers all the things that we had uh, listed of talking about. Is there anything else that you've thought of that you'd like to kind of comment on for this project?
Yeah, I'm just surprises about the CircleCI is definitely a big benefit to me. I actually look forward to use it in the future for other projects.
Excellent. All right. Well, thank you for taking the time to record this. And in 3 seconds, I'll shut off the recording.
Thank you.